channel. In this video, we're going to have a continuation of this major paper last minute revision for 2025. So we are going to pick from the question that we had left. So remember, guys, we had looked at some of the questions here. We rediscussed how to work them out. So we're going to pick from right from question number 8. And here we are given triangle ABC, which is a right angle triangle, and then we are told that AEC and ADB are straight lines, ED and BC are parallel. Then we are supposed to prove that triangle ABC is similar to triangle ADE. Something that we need to remember, you can be able to prove whether triangles are similar by looking at common angles. And in this case, we can be able to attest that angle A is a common angle between the two triangles that we are being told there. So for that reason, we are going to compare also and say that in the two triangle ABC and ADE, we have a common angle, which is angle A. And then we are going also to look at angle B and angle D in this case. So which means that we can be able to say angle EDA is equal to angle CBA. Also angle AED is equals to angle ACB, which is what, and this is equal to 90 degrees. So we can see here corresponding angles are equal. Then we can now be able to conclude that the two triangles are similar due to the condition of angle corresponding are being equal. So that's basically what we are going to say in that particular part. So we are going to look at how to find the length EC, and we are going to find this length EC here. So in that case, we are going to look at similar sides. So we can say ED over CB is going to be equals to AE. In this case, we shall say AE over AC. So we can be able to let this to be X so that we can be able to substitute. We can see here ED is 20 centimeters, and then we have this AEX, then the other part, this one is going to be basically 18, not minus, it will be 18. So making X the subject of the formula, we are going to get our value of X being equivalent to 12. So which means that X is 12, then we can be able to find this the part here, it will be 18 minus 12. So meaning that EC is going to be equivalent to 6 centimeters. This is going to be 6 centimeters at that point. So let me just transfer this here so that we can be able to have our working well stated at that point. So moving to the next part, before that, let's find our EC, which was actually 18 minus 12, that was 6 centimeters. So basically that's what you are supposed to do when you are given a question like that. And if you are new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to upload more tutorials, you'll be notified. In ProfLearn YouTube channel, I do maths and physics, GCSE, IGCSE, and further pure math as well as physics concepts will be uploaded in this particular channel. So guys, if you're new here, consider subscribing so that once I'll be doing more tutorials, you'll be notified. Let's continue. Let's move deeper and get to see where we stopped at. All right, so moving down to where we left. Okay, so we're going to move at this question of transformation of solids, and here we are supposed to fully describe a fully single transformation that maps A to B. Of course, if you have a physical paper, you can be able to see the rotation, anti-clockwise about the point -10. So since I'm working this on the software, I really don't have the functionalities through which I can be able to show the workings. Let's move to the next part. We're supposed to draw an enlargement by scale factor half, center -1, -2. So the first thing that you're going to do is to identify the center of enlargement, and that is going to be -1, -3. That is the point. Then you draw a line joining the points there, like that. Then you are going to measure a half, the entire length of each particular line, and identify the midpoint of it, because it was enlargement of a half. So basically that's what you're going to do here. A half of this is here, a half of this one will be 3, and a half of this is going to be 1 +2 somewhere here. The next part is to join all the points by a straight line like that. Making mistake there, let me just join properly. Yeah, so that's the triangle that we have that has undergone an enlargement of a half. So meaning that the area of this is a half the original area that was there. So this is the new area that we are supposed to come up with. Moving further to number 10, it was a proof about two consecutive prove that the difference in the square of two consecutive even numbers is also a multiple of 4. Is a multiple of 4. So in that case, we know that an even number is actually 2n. Then the next consecutive even number will be 2n plus 2. And then we're going now to square the two numbers and then find the difference. And you can see now here, we can be able to cancel 4n squared and 4n squared. So we're going to remain with that. And something that you're going to realize that once we have this, we can be able to express this number as what? Let me just show you what I'm trying to say. Let me just show you here. Once we have that, we can be able to so meaning that once we have this, we can be able to factor 4 out. This is going to be 2n plus 1. So since we can be able to see that this number can be expressed as a multiple of 4, you can see now you are factoring out, and this is a proof that is a multiple of 4 at that given point. That's basically what you're supposed to do in that particular question there. So the next part we are going to look at, we are told that t is inversely proportional to w. So meaning that we are going to say t is inversely proportional to w. We shall write 1 over w. Next is removing the sign of proportionality by introducing a constant. So we shall say is t k over w. And the second part, we can be able to substitute the value of t and the value of w in order to find the exact value of k. So k is 120, and that means that we can be able to say t can be written as 120 over w. But further we are told that w is directly proportional to this cube root of d. So which means we can say w is equals to, we introduce a constant there, m cube root of d, and then at that given point we are told when w is 1, d is 8, so we can be able to say 1 is equals to m cube root of 8, which is going to be basically times 2, and which means that m is equals to a half. So meaning that t can be written in terms of d, so this is going to be over w, but w is going to be what? A half cube root of d, which means that in this place we have w in t. We can be able to replace that. We can be able to replace it with, a half cube root of d. So basically that's what we're going to have. But now, of course, if you take 120 divided by a half, is going to be 240. Then we shall have 48t is equals to 240 over cube root of d. So we are trying to find the value of d when t is 48. So at that given point, we can be able to make d the subject of the formula, whereby we're going to simplify this. We shall get 5. Then finding the cube both sides, our d now translates to be 125. So basically, that's what you are supposed to do whenever you are given a question like that. So we can be able to transfer that down here just to make the examiner happy. Question number 12, in GCSE Math, you may be given question like this from the graph, and then you are expected maybe to find the gradient of the curve. So something that you need to remember here is that you need to locate the point where you are told like that, and then draw a tangent. And remember, a tangent is a line that is touching a curve at one specific point. Then we can be able to do rise and run. Okay, we have run and rise there. Then we can be able to check what is the run, because you can see the point is running from all the way 1 to 4. The run is approximately 3, and the rise, to be precise, around 34. But I'm going to approximate, because in this question you are told work out an estimate of the gradient. So we are just estimating, and remember, this paper is not calculator, so it means that you need to have values which you can be divide. So I'm going to approximate that to be 30, around 30, so that I can be able to find the gradient. So I'll say that is around 30. So 30 over 3, approximately 10. So an estimate, because the question was asking you to state an estimate of that. So going down, you are asked, what does the gradient of this represent? So something that you need to ask yourself, what is it on the y-axis and what is it on the x-axis? If it is a velocity against time, the gradient is going to represent the acceleration of the object. But if it was distance against time, the gradient was to represent velocity. But also you need to remember here that area under this graph, because it's a velocity time graph, is going to represent the distance covered. But the gradient of this graph is representing acceleration, and basically we are going to say acceleration of the object. Moving further, we are going to work out an estimate of the distance traveled by the particle in the first 6 seconds. So with 3 equal strips, then we're going to, let me just erase this so that we can have our strips well demarcated there. You can see our strips, the 3 strips, and then we can now apply trapezium rule in order to work out this. You can see the height of each of the strip is actually 2, so we can be able to apply trapezium rule here so that we can be able to find the area. So remember, trapezium rule is a half h into end lines, that is y naught is the y naught is going to be the at time 6 0, at time 0 we are going to have 0 velocity, and at time 6 we are going to have yn, the last the height of the last strip there, which is going to be 60. So we are going, the middle one you are going to times 2, then you close the bracket like that. So let's see how do you really apply this. So let's see how you're going to apply that. We are going to write the formula for trapezium rule, and then this is the formula. We shall use that trapezium rule. So you need to understand this one is going to be our y naught, and this one is going to be our yn, the last one. So we are going to, and the height of each strip is going to be 2 units. So this is going to be a half. This is the height of each unit. So we shall say this is going to be a half times 2, and this is going to be 0 plus 60. Then this is 60, and then this 30 there. Then we can say now the middle one is 30 plus 50 times 2, Then if you simplify this, you are going to get 60 plus 160, which is going to translate to 220. So this 220 is the area under the graph using trapezium rule, and that's going to represent the distance covered. So we're going to, let me transfer this part down there so that we can have somewhere all the steps shown in this space that was provided. So basically our answer is going to translate to 220 meters. We have question 13. Question 13 is talking about recurring decimals, and we are going to see you are given x is a recurring decimal of 0.2, and this 0.2 has a dot at the top, so it means that it's going to be 0.22222, and the 2 is the recurring digit there. Then for y is 0.681818181 is the one that's going to recur. So the first thing that you're going to do in order to find x and y is to ensure that you are expressing those into, you express those decimals into fractions so that we can be able to multiply them. And in that way, we're going to say x is equals to 0. X is equals to, yeah, we shall start with the first one here. X is equals to 0.2. 10x will be 2.2 because 2 is the recurring digit. So meaning if you are having x is 0.2, 10x will be 2.2. Then you can see now, when you have x and 10x, if you subtract 0.2 and 2.2, you're going to have 0 at the end. So that's what we are targeting. So it will be 10x minus x, which is 9x, is equals to 2. Then we can say now, therefore, this is going to be 2 over 9 as the fraction for this. And then we have y. So we shall say y is equals to 0.681. 10 is going to be equals, we shall shift the digit to the front so that we shall have 10y is equals to 6.81. Then I'll do 100y. That's going to be 100y, going to be 68.18. Then I'll move to 1000y. That's going to be 1000y is going to be what? 1000y, I need to write y here. That is going to be 681.81. So you can see when you are having 1000y and 10y, the digits after the decimal are the same. So meaning if you're going to subtract, you're going to have 0 after the decimal, and that's actually what we are targeting. So whatever you're going to subtract here is 1000y minus 10y, and this is going to translate to 990y is equals to 675. So if we divide by 990 both sides, you shall have our y in terms of a fraction being equivalent to 675 over 990. So now with this, what are we going to do with it? We are going to, because we were told to find xy, so meaning we're going to multiply the two fractions, and if you multiply that and simplify, your answer is going to be 5 over 33. So basically that's what you are supposed to do in that particular case. Now we have question 14 and the rest of the questions that are remaining. We're going to look in that question in part 3. So if you are new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to do more tutorials, you'll be notified. See you in the next tutorial.